Okay. It is Friday. Okay, so we are on week 4, and for networking, this would be day 7. Alright, so today we took a look at these particular things. We talked a little bit about packet tracer and labs. Make sure you answer the questions. Submit 3 things for the packet tracer. Make sure you review the comments I make on all the assignments. Packet tracer, you should have a goal of getting 100% on those. Again, don't work forever, but let me know if you have some issues. Exams, okay, don't wait until the last day, and make sure you're working on the content during the week for the course. Don't be waiting until Fridays or the last day. Have some issues, let me know ASAP. Okay, it could be anything in terms of the course. Now I know a lot of you are just worried about getting the work done, but you got to do the work, plus you got to learn the material, and you have to make a conscious effort of doing that, not just getting it done, but being able to say, okay, going back and looking at it, okay, do I understand what we were doing here? Why do we have passwords on the switch? And what does it mean to put an IP on a switch rather than just be able to do that? That's important. Today, we talked about this idea of, really a lot of this is stemmed around this whole idea of protocols. How do we do communications? That makes sense? How do we do communications? These rules. Rule establishment. We establish rule, sender, receiver, we have a protocol, timing, confirm and acknowledge that we've got the information. Talk more about that later on. You can encrypt message, you can encode it, a lot of messages nowadays, okay, so it might just be in American's standard code of information interchange, ASCII. Let me write that again. American Standard Code of Information interchange. We talked about that in class before. Other types of coding or encrypting. Message formatting encapsulation. Right here, we're going to talk about our example of encapsulation. We have our data in here and it gets encapsulated. How big the message is, right? We can't make them an infinite amount of size, so we have to cut down the data to a certain size, add our extra information before we send it. Timing, how do we access, how do we control the flow, and how long do we wait before we time out. And when we deliver, could be a unicast, we send it, we receive. Could be a multicast, we send it and it goes to a certain set of people. Okay, so it might look like this. We send it, then eventually it goes to just these people. Or a broadcast goes to everyone that's listening on that particular network. You got it? Listening on that particular network. Now let's take a look here at some of this information here in terms of encapsulation. Okay, we did a lab work so we had something to use in order to talk about this. So we set up that lab, and everybody had a switch, and they're all connected. Then we talked about, and we can review this again too. So you have your data, for example, and the ping it sends part of the alphabet. And then we encapsulate that with IP addresses, source and destination. The destination's key in terms of sending it. This is often referred to then as a packet. Then we encapsulated that as we get closer to actually sending it somewhere, and then we have that media access control. Source and destination physical address, the MAC address. Now we have a frame, and then we can send the frame out to the wire using our OSI model. So if we are coming down from whatever software we're using set up a session. Then we get to the transport layer. It decides how it's going to transport it, TCP, UDP. Then we get the network layer, put the IP addressing on it. Data link layer, we put this addressing on it, and there the bits go. We send them to the other device. When they come to the other device, we take this off, okay, then it looks at this. If this matches, then we eventually get the data back to wherever we're sending it. Okay, so we look at this is the OSI model. And here is the TCP IP model. And they match in a lot of ways. For example, these three layers in the OSI match with the application layers in the TCP. We'll talk more about that later on. How we transport the data, those look the same. Either we're looking for keep track of the packets and make sure we get them all, or we just send them and hope they get there. Okay, and we talked about the differences here, like a basic contacting a web page would be TCP, streaming with Netflix or YouTube or whatever would be UDP. At the network layer, we're worried about the best path. On the TCP model, they call that the internet layer. Okay, and this is where we do the IP addressing. Okay, and then down here, the data link layer, okay, and the physical layer, actually putting them, like if it's Ethernet, we have a MAC address, or sometimes called the MAC layer. This is where we get it prepared for that last link, the data link between the two locations. Okay, coming out of your PC and going to that web server somewhere. Actually, this would just get you from your PC to the switch, primarily. In the TCP IP model, okay, that's actually called network access, which makes sense. This is how we're going to access the network. Okay? Alright. So, we'll talk a lot about this over the next year and a half. Yeah, believe it or not. Yeah. So we finished up today. We loaded up Wireshark. It's free. You can download it and install it on any computer, and what it does is it looks at packets moving through your NIC, your network interface card, okay, and it watches the traffic. And in this case, what we did was we looked at a ping, and this was the data part. Let me see. All right, that's a little more clear. This was the data part. It's the alphabet right here. And then all this up here was the addressing. The IP addressing in here somewheres, and the MAC addressing here somewheres. And we'll be looking at that a lot more on Monday. Alright, so we're pretty much finishing up Chapter 3 and moving on to Chapter 4, Network Access. Okay, talk a little more about the details of what's going on here. And that's it.